The square root of x times x minus 1 is a product of functions, so to take its derivative, we can use the product rule. Now, alternatively, you could distribute this square root of x through the parentheses, rewrite everything with exponents, and just use the power rule, but for practice, we're going to use the product rule. I've written the product rule here for your reference. The derivative of a product of functions f times g is f prime g plus g prime f. We'll say that the function on the left is f, so we'll say that the square root of x is f of x. And the function on the right is g of x, so g of x equals x minus 1. So here those labels are. Let's go ahead then and apply the product rule. We begin with f prime g. Now, f is the square root of x, which you should recall is the same as x to the 1/2. So to find f prime, we'll use the power rule on x to the 1/2. Thus, we take that exponent of 1/2 down in front as a factor, which you see there. Then reduce the exponent by 1. 1/2 minus 1 is negative 1/2. So this here, 1/2 x to the minus half, that's f prime. We then have to multiply that by g, so you see that multiply by x minus 1. Then we need to add g prime f. G is x minus 1, so g prime is just 1, the coefficient of x. Thus, g prime f is just 1 times f, so just root x, so plus root x. Now we can do some simplification by distributing this term across the parentheses. 1/2 x to the minus half times x. We can do that using our exponent rules. Add those exponents together. Negative half plus 1 is positive half, so that's 1/2 x to the positive half. Then 1/2 x to the negative half times negative 1 is just negative half x to the negative half. And then we still have the plus root x at the end. Now, you should recognize that root x, again, that's the same as x to the half. So we actually have like terms here, a half x to the half and a whole x to the half. Thus, if we add those together, we get 3/2 x to the 1/2, because this is 1/2 x to the 1/2, and this is 2/2 x to the 1/2. So in total, 3/2 x to the 1/2. And then, of course, we still have the minus half x to the negative half. We could leave our answer like this if you like those rational exponents, especially if you had to take the derivative again. I would probably leave it like this. But if you want to change the exponents into radicals, we could rewrite this as well. X to the 1/2 is, of course, just root x, and x to the negative half is x to the positive half if we move it to the denominator, and then x to the positive half in the denominator would be root x in the denominator. So we could rewrite it like this, that's fine, and if you want to combine the fractions, we could multiply this term by root x over root x, because the denominator of this guy is 2 root x, and this denominator has a factor of 2, but to get common denominators, we would need to get a root x down there. So multiply this by root x over root x, that will get us common denominators. Now that looks like this. So we have 3 times root x over 2, and then we multiply it by root x over root x. Now in the numerator, root x times root x, that's just x. So then we would have 3x minus 1 all over 2 root x, and that looks like that, which is a pretty nice final answer. So either way you want to write it, that's the derivative of root x times x minus 1. Let me know in the comments if you have any questions, and be sure to check out my Calculus 1 course and Calculus 1 exercises playlists in the description for more. Thanks for watching.
Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about. Stressed out, honey, I've been stressed out lately. Don't know what's what, don't know what I'm stressed about. Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about.